This is Geometry, Semester 2. It's the unit on conics. It's unit number 7. And it's the unit on Euler's formula for a polyhedra practice. It's lesson number 4. It's on creatormath.com under the Geometry tab. You might have to type in creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. And with that, I'm going to model for you, we're going to look at the notes. So maybe just to back up a little here. Here's creatormath.weebly.com. If you look at the home page, you should recognize it right away because it's got my picture on it. And then we're going into the Geometry tab because that's where all the notes are for geometry. We're passing by the vocabulary and coming right here to the table of contents. Not very far down. It says Semester 2, Table of Contents. This is what gets copied onto your composition book on pages 2 through 6. And it's rather long. It's the table of contents for the whole semester. Once you copy it once, though, it's got all the page numbers associated with it. And that's how you know where all of these lessons and units go in your composition book. So this is trig, special right, volume, conditional probability, circles, angles, and arcs, surface area, and here we are at conics. So conics, this is the 4th lesson within the unit conics. It's Euler's formula for a polyhedra. At this writing, it goes on page 133, 134, but please check this table of contents. When you're looking at this, it could very likely be different. Here are the notes that go on your pages in the comp book. And you do those notes before you do these problems. The notes are there to help you and to give you guidance on how to do the problems, right? So Euler's formula for polyhedras, and it is given the number of faces, vertices, and edges. Can we generalize a method to relate those 3 aspects of a polyhedra? So we have Euler's formula here. And it says vertices minus edges plus faces equals 2. So V minus E plus F equals 2. We'll explain a little bit more as we go through the problems. How do we pronounce Euler's formula? The answer is Euler's formula. So, you know, the typical mislead is it looks a lot like Euler's formula, right? But the proper pronunciation is Euler's formula. And I'll mix it up every once in a while. Euler's is the one that we need. So here's an example. If a polyhedron has 4 faces and 4 vertices, how many edges must it have? So we use the formula V minus E plus F equals 2 and plug in what we know. We know if a polyhedron has 4 faces, so for F we have 4 vertices, for V we have 4, and we're just going to solve and find out how many E's we have. We have 6. So what shape is it? A tetrahedron. This is a drawing of a tetrahedron here, right? Tetrahedron has 4 triangles put together on their edges. But what we're looking at here are V for vertices. That's a vertex, right? Right here's 1, 2, 3, 4. So 4 vertices. Each one singularly is called a vertex, but plural is vertices. Then we're looking at edges. So each of these lines is representative of an edge. Right? And there's a dashed edge behind the shape. Dash means hidden, means we can't see it unless we rotate it. Then we also have, what else are we missing? Faces, right? F. So faces are, like this is 1, 2, 3, 4. As we look around the shape, there's 4 faces here. So that's what we're plugging into this Euler's formula. And it's very cool because we can look at a shape and predict the different number of edges, faces, and vertices. So if a polyhedron has 12 edges and 6 faces, how many vertices must it have? So we just plug in the values again. V minus 12 plus 6 equals 2. Solve for V and we get 8. And what shape is it? It's a cube. So look at a cube. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. That's where we came up with 12E. That was given. Now we're looking at faces 6. There's 1, 2, 3, 4, 5, and 6. 6 faces to a cube. And then we're asking how many vertices are they. We solve for 8, so let's just count. Here's a vertex here. 1, 2, 3, 4, 5, 6, 7, 8. And the whole thing balances out according to Euler's formula. So given a polyhedron, we can relate the number of faces, vertices, and edges by Euler's formula. Faces are the flat surface of the three-dimensional shape. Vertices are the corners or angles of a three-dimensional shape. Edges are the lines which connect the faces of a three-dimensional shape. And a polyhedra is a three-dimensional shape with many faces, vertices, and edges. All right? And here we can start to build a chart of faces, vertices, and edges, and then start to label the different three-dimensional shapes. On the notes are some problems for you to do, and that's going to look a lot like the problems we do right now. All right, so let's see if we can work through some of these problems. What is the right way to pronounce Euler's? Come on, pen. Euler's formula. So we're going to go with that. We've been talking about that. Now you know that, hopefully, and you can stick to that pattern. Number 2. What three aspects of a polyhedron are related with Euler's formula? Use Euler's formula. They give it to us here. They give us the formula. So V is for vertices, E is for edges, and F is for faces. So faces, vertices, edges. What is Euler's formula? Well, let's just take it from here. V minus E plus F equals 2. V minus E plus F equals 2. So I like these problems so far, because they're easy for me. Let's see. In Euler's formula, V minus E plus F equals 2. What does the V represent? Oh, wow. Okay. Vertices. What does the E represent? Edges. Wow. I like this problem set so far. They're really not working my brain too hard at all. But at least they're giving me a good background. I'll understand this pretty clearly. And what does the F represent? Faces. All right. Let's see. Are they going to give us a problem here? Yep. If a polyhedron has 5 faces, so let's start out with this. V minus E plus F equals 2. That's what we're starting with, Euler's formula. We're told we have 5 faces, so let's put a 5 in here. We know we have 2, that's part of the formula. 6 vertices, so putting 6 in here. How many edges must it have? So we're going to put minus E. E is our variable, we're just going to solve for that. Let's see what we can do. A 6 and a 5 are combined like terms, or CLT. 6 and 5 is 11. What we have here is 11 minus E equals 2. Make sure to maintain the minus on the E, because that's can't go anywhere yet. Let's subtract 11 from both sides. Disappear here. I'm going to come over here and continue. We have a minus E equals a 2 minus 11, negative 9. Well, negatives on both sides, or anything on both sides of an equation, we can cancel both to balance it. Or you could multiply through by a negative 1, or divide through by a negative 1. Whatever you do to one side, you do to the other. Either way, we can drop the negatives on both sides, and we get 9 edges. If a polyhedron has 36 edges and 14 faces, how many? Okay, so it looks like a repeat problem. So we've got V minus E plus F equals 2. We fill in 14 faces equals 2. 36 edges. There's a plus here, a minus here, and a V. So negative 36 plus 14 leaves us with a negative 22. Add 22 to both sides. V equals 24. So 24 vertices. Could a polyhedron have 10 faces, 3 vertices, and 11 edges? Well, let's see. We know that we need this equation to work out. V minus E plus F equals 2. How many vertices? 3. How many edges? 11. And how many faces? 10. The question is, and we're going to put a circle around this equals, because we want to know if it's true or not. If it's true, then the answer is yes, it can have this, right? But if it's not, then no, it cannot have this, right? So we have negative 11 plus 10 is negative 1, and 3 minus 1 is 2. Let's see. Let's do it the other way. 3 minus 11 is negative 8. Negative 8 plus 10 is 2. Could a polyhedron have this? Use Euler's formula. I don't know. Looks good to me. Unless I'm doing my math wrong, you guys can check that later. If I am, I stand corrected. But so let's see, yes, because that would combine using Euler's formula, which is V minus E plus F equals 2 plus 2. So I'm not sure if they're tricking me or not, and I'll look into this one and see if I can correct it by the time you get it, if it's wrong. Otherwise, I believe it's yes, it can. All right. This is Geometry, Semester 2. Follow this. It's the Conics unit, and it's lesson number 4 on Euler's formula for a polyhedron under creatormath.com on the Geometry tab. Hope this helps.